Okay, so to get ready for the log test, I've been asked to go through number 3, and so we'll look at solving a log equation where we have different bases. Here you can see base 3 and here 9. So let's have a look here, and first let's try to get these things the same base. There are two different methods that we could use here. In class I showed you this, and then if we take this and we do 1/2, 2, we can make this a 3 because we know 3 squared is 9. Okay, so as we get that, then our next step, just some simple algebra here, log x of 3, 1/2 times 1, so then you have plus another one, log base 3x, and that equals -4. Okay, so then it looks like we have 2 log base 3x equals -4. Alright, dividing both sides by 2, log base 3x equals -2, and changing this to the indice form, 3 to the -2 equals x, and we see that x is 1/9. Okay, for the next one, part B, we'll use a slightly different approach. We'll use the change of base. Just show you two different methods here. Then you have log of x over log 4. Then we're going to add log x, and here you've got log 16, and that equals -3/4. Okay, so using the change of base, you don't have to think about, like we did over here, what could happen, and you just have to be a bit more formulaic. It takes a little bit more work, but here we can now go and try to find a common denominator. So let's make this 16. So what do you have to do to this side? Throw a 2 out front. Okay, so multiply top and bottom by 2. You have 2 log x over log 16. Okay, because 2 log 4 squared, 4 squared is 16, so we have the common denominator. Now I'm just going to write this plus log x, since we're over the common denominator anyway, and that equals -3/4. Okay, so 2 log x and a log x gives me 3 log x's, and any base we like at this point, and -3/4 log 16. Good. Then this gets a little bit messy, but what we can do here is the 3 can divide on this side. -3 divided by this 3 is -1, so we have -1/4 log 16. So log x equals -1/4 log 16. And then this can come up here using the laws of logs, and we end up with log x equals log 16 to the -1/4. So the 4th root of 16 and negative gives us x equals 16 -1/4. 4th root of 16 is 2, and negative puts it down, so x equals 1/2. Okay, so that's a method using the change of base. Alright, then you can see it takes a bit more work, but possibly is a little bit more formulaic, and you can understand where it's coming from there. I'm going to do part C now. Can't remember, I think this, there we go. Look at that giant eraser, very impressive. Okay, so the next one you see you have a base 5 and a base 25. So I'm going to take it and I'm going to approach it similar to we did in the first case. Okay, so log of x base 5, and then I'm going to add 1/2 log of x base 5. Okay, and that is -3. Good. So 1 plus 1/2 is 3/2 log base 5 of x equals -3. Taking this side, dividing by -3/2 gives log base 5 of x equals -3/3 is -1 and times 2, so -2. And from here, just convert from the log form to the exponential form, so 5 to the -2 equals x, right? So therefore, we see that x equals 1/25. Good. So